All right, let's continue building on this idea of critical value. So we've already seen that visually, here it is, my distribution, that when I take samples, I know that I have, and again, no, that's a probabilistic statement. So we're fairly confident that if this is the true center, and I were to go, for example, 2 standard deviations, instead of writing out the number of standard deviations, I'm just going to write Z. And then do the same thing on the left-hand side. So here, think of the specific number 2, kind of looks like a Z. But more generally, Z could be a different number. And what we're going to observe here is that because I have an idea of the fraction of results that land close enough in this interval, then this is going to be called a confidence level. So again, it goes back to that idea. I'm fairly confident that if I were to take a single sample, I will land somewhere in the blue. So that refers to this idea of confidence level. So we're going to call that CL. CL, for example, think of like 95%. So I can ask, I want to be 95% confident. And this simply refers to the proportion or the fraction of results of your sample mean, right? That which are close to the true center, which is mu. So whenever I mention confidence level, I can alter that. Instead of 95, I could, for example, say, let's make that 99%. And that just simply means that you would go further out. So because I don't want to just stick with Z equals 2, and I want to have that flexibility of deciding how confident do I want to be? Do I want to be 99% confident or just 90% confident? We're going to go ahead and write this value here because we're going to notice that the area in the tails, if in the middle I have some measure of confidence, then the area in the tails is going to be 1 minus that confidence level. And so that's denoted by alpha. So alpha ends up being the proportion of values that land far away. And it's the combination of both of these tails, the tail on the left and the tail on the right. So both of these tails put together have an area or proportion of results of alpha. So this is called the significance level alpha. And what I want to notice is that if the area in both tails is alpha, then each tail has an area of alpha divided by 2. So this tail here is alpha divided by 2. And therefore, using the notation that we covered previously, right, with the right tail notation, we're going to go ahead and denote my confidence level by this critical value. So a lot of terminology here. Z sub alpha over 2 is called the critical value. And so that's the critical value that corresponds to the confidence level and also to this significance level. So whenever we say level, you're either going to give me the significance or you're going to give me the confidence. They're both the same because with one, we can find the other, right? If your confidence level is 90%, then your significance level alpha is 10%. It's just whatever's missing to get to 100. And with either one of those, you can go ahead and find the critical value. So let's go ahead and phrase it now with that context. So let me find the critical value, Z sub alpha over 2, which corresponds to the given level of confidence. Remember, level of confidence is just you now saying, I am fairly confident I will be able to obtain a sample that's close enough to the center, the true center. So here's our first example. Can you find the critical value Z sub alpha over 2 which corresponds to the given level of confidence of 95. Here's the way that I want you to do this. Whatever information is given, sketch your distribution. You know it's going to be normal. And then write this down. 95% confidence, that's the middle. So most of the observations will land here in the middle. We can see that. And then you go ahead and you find the significance level. So this means that so this is my confidence level. So alpha is 1 minus the confidence level. So it's 1 minus 0.95. Because we got to remember that 95% is 95 out of 100. So therefore, alpha is 0.05. So the area in the tails, here we see them highlighted in red, is 0.05. Therefore, the area in a single tail, just one of them, is alpha divided by 2. So therefore, my critical value, the cutoff point on my number line, this unknown value, is called Z sub 0.025. Because that's what you get when you divide 0.05 by 2. So we can go ahead and use StatCrunch to find this. Now, using StatCrunch, remember that we can go ahead and write out a probability statement. So this we're going to find by the probability that my random variable Z, standard normal, is greater, lands to the right-hand side of this unknown value, has to be 0.025. So probability that we land to the right, 0.025, that's 1.96. And we're going to be seeing that number a lot because 95% confidence is one of our standards. That's actually where we get that roughly 2 standard deviations. Within 2 standard deviations of the data, we have 95%. You can see that the actual number now of standard deviations is actually 1.96. So it's not quite 2, but it's pretty darn close. All right, let's go ahead and find the critical value corresponding to 92% confidence. So that's part B. So go ahead and repeat the same steps. I can help you by starting with our sketch. And remember that we want 92%. So that means alpha equals 1 minus this confidence level. And therefore, I can find the area in a single tail and then determine the critical value. So go ahead and wrap this problem up. And I'll see you in the next video.